Okay, now what we want to do is we want to try to solve the same question but using this second formula here. Now what you need to think about first is, what does this mean anyway? So one of the first things you need to think about is here you have f of c minus c. So what does that mean? If I think about this in terms of my function, so this is telling you what point are you trying to find your gradient at. Whatever point that is, that's your c. Okay, so in this example, we want to find it at x is equal to 2. So your c value is going to be equal to 2. Okay, so wherever you see c, you put 2, and obviously f of c is equal to f of 2. Okay, and your second point is going to be located at x. And we don't know what that point is. That's just an arbitrary point which is going to be left in the general format. So now, using this formula, we want to find f dash of x, then limit of fx minus fc over x minus c, and we want to find a limit when x approaches c. Okay, so what we want to do now, sorry, that needs to be f of c, because we're trying to find the gradient of this function at point c, and therefore you find the gradient of the function at point c, and therefore that needs to be f dash c. Okay, so now what you say is, firstly, let's figure out what our fx is, what our fc is, what do they correspond to. So again, they've given you a function y is equal to x squared plus 5. That means that your f of x, so your function, takes values of x, and what it does to them, it squares them and adds 5 to them. Okay? So if it takes value of 2, so remember f of c is actually f of 2. So let's think about it like this. If I had f of c, what would f of c be? Again, remember your function takes any input you give it. It doesn't care whether you give it x, it doesn't care whether you give it c. Whatever input is, puts it down, it squares it, and adds a 5 to it. Okay. But your point c now corresponds to x is equal to 2. So it corresponds to the value of 2. They've given you an actual concrete value. So we're going to work with f of 2, which is going to be 4 plus 5, so that's 9. Okay, and obviously your c values too. So now that we know these, we can just substitute them into that function. So f dash of the point where we want to find the gradient at, which is going to be point 2, is going to limit as this value of x approaches 2. And your fx, which is just your x squared, plus 5, and you subtract the y value at that specific point, which in this case is 9 over x minus the point where you want to find the gradient at, and that point is 2. Okay, so it says f dash of 2 is going to be limit as x gets closer and closer to 2. Now, just simplify that. That becomes x squared minus 4 over x minus 2. Now, what we want to do is we want to simplify this first. Remember that with limits, if you substitute this in now, what you're going to get is you're going to get 0 over 0, and that's undefined, and therefore your limit's not going to work. So for limits, what you need to do first is you need to simplify this function as much as possible. Now you have x squared minus 4. Now remember that that is in the format of a squared minus b squared, and from the factorization lectures we know that this is equivalent to a minus b times a plus b. Again, if you're a bit rusty on this, you can just revise them in the appropriate lectures. Okay, so now using this formula up there, what I can do is I can just say that becomes x minus 2 times x plus 2 over x minus 2. That cancels out with that, and therefore I have limit x goes to 2, x plus 2. Now that I've simplified this as much as possible, I can now substitute this value in here and find the actual limit. So that becomes 4. Now what this is telling me is that the gradient of this function at point 2 is equal to 4, which is exactly what we found when we used this formula as well. So you can see that there's no difference between the two formulas.